Types of salts. Normal salts, which are formed when all the replaceable hydrogen ions in the acid have been completely replaced by metal ions or metallic ions. Like in this case, hydrochloric acid reacts with sodium hydroxide. Hydrogen ion of HCl is completely replaced by sodium. So we have the product sodium chloride. So this is the sodium chloride is an example of normal salt. Next comes the category of acid salts, where we see that all the replaceable hydrogen ions present in acid are not replaced by metal ions, rather they are only partially replaced. Let us see the example. Sulfuric acid undergoing reaction with potassium hydroxide. Sulfuric acid has two replaceable hydrogen ions, but out of two only one is replaced by metal. Therefore, we have the product potassium hydrogen sulfate, KHSO4. So this KHSO4 is an example of acid salt. Next comes the basic salts, which contain hydroxide ion. They are formed when there is insufficient supply of acid for the complete neutralization of base. Let us see the example. Zinc hydroxide is the base used here. It reacts with hydrochloric acid. We have formation of ZnOH here. So you see hydroxyl ion is present in the salt. So this is an example of basic salt. Next comes the category of hydrated and anhydrous salts. Hydrated salts are those which contain water of crystallization. A question comes here, what is this water of crystallization? This is the chemically combined water which is present in the salt. So those salts which contain this water of crystallization, they are termed as hydrated. Those which do not contain this water of crystallization, they are called as anhydrous. In category of hydrated, we have seen the example of copper sulfate, CuSO4 0.5H2. This salt actually contains 5 molecules of water of crystallization chemically combined with one molecule of the salt. So this is an example of hydrated and anhydrous, which is free from water of crystallization. Some more examples are given in the table, which is shown below. These are some hydrated salts which are actually present in the form of their crystals in different colors. The examples shown here just to make you understand that hydrated salt exists as small crystals of varied colors. Then we have these uses of salts given. We know salts are used for various purposes. Then next we have pH scale, which is actually a scale designed by Sorensen to find out the nature of different solutions. pH scale is actually a measure of the relative acidity or alkalinity of a solution. If we want to define it in mathematical terms, we can say it is the negative log of hydrogen ion concentration. Now you see this pH scale shown, it is showing different colors at different pH values, and it also, these different pH values represent the hydrogen ion concentrations of the solutions, which actually help you to identify that among the two solutions given, if two solutions are acids, which of them is strong and which is weak. In general, when we move on a pH scale from 1 to 6, the acidity increases. Acidity actually is decreasing, but the hydrogen ion concentration is actually decreasing. So we can say in general terms that till pH 6 is acids. If we have two solutions, one with pH 1 and other with pH 3, among the two, whichever is having lower pH value, that will be more acidic. And which is having among the two, the lower pH value will be more acidic in nature. 7 is actually the neutral point, and then above 7 till 14, the basicity goes on increasing. So if we have two solutions, one with pH 11, other with pH 14, among the two, more basic nature will be for pH 14. Then here they have shown you some pH values for different substances which help us to find out that for a given solution which among them will be standing in which pH range. Then you see the indicators which we use generally for identifying acids and bases besides pH scale. The difference between pH scale and indicators is majorly this, that when we talk of indicators, indicators help us to identify acidic or basic solution, no doubt. But it is not able to tell us that among the two acidic solutions, which will be more acidic and which will be less acidic, which will be more acidic, which is less acidic, which is identified by pH scale. So this is the advantage of pH scale over normal indicator.